Hello, welcome you all for this video lecture. Myself, Dr. B. R. Krishna, Professor and HOD, Department of ECE, St. Martin's Engineering College. Today I am going to deliver a lecture on how to interface LCD to the 8051 microcontroller. So, what is LCD means? LCD is a liquid crystal display. So, generally, we have a for displaying a text, we have this LCD, that is 2 by 16 LCD. So 2 by 16 LCD means we'll have a 16 characters with 2 rows. So in each line, in each row, we can display 16 characters. So that we'll be having 2 rows like that. So there are different kinds of LCDs are there. So this is one more example of graphical LCD. So like that we can have text LCD, video LCD and a graphical LCD. So whatever the LCD that I have displayed here, both are monochromic, that is it can display in only in black and white. We cannot have color. Color if you want to go means we can go for a TFT. As per our syllabus, we have only LCD interface where text displaying of LCD only is there, right? So LCD can display numbers, characters and graphics, right? So as I said, we are having 16 by 2 LCD. So 16 by 2 means it is having 16 characters it can display in a single row with 5 by 7 or 5 by 8 dot matrix. So total number of pins will be 16. Out of these 16 pins, there are 14 pins that are useful. So first pin is VSS, second pin is VCC, that is we are connecting to plus 5 volts, and third pin is V0 for contrast adjustment. So where we are using a potentiometer for adjusting the color contrast by increasing the brightness or decreasing the brightness, right? So then we are having the three important registers are there. So that is register select, read write and enable pin. So with the help of these three pins, we will be writing the program for the LCD. So then we are having 7 to 14, D0 to D7 where the data will be displayed or will access the data pins used for 8-bit or 4-bit mode. So these are the 14 pins that are useful in the, that are there available in the LCD. 15 and 16 are LED plus and LED minus pins. So as I said, like we are having the two registers, three registers are there. So register select. So one first register is register select. So where in the register select, so whenever the register select is 0, so we are having two commands are there. So where we will be sending the commands or we are selecting the command code or we are selecting the data register. We are selecting the command code or we are selecting the data register. So whenever we are making the RS is equal to 0, that is we are selecting the command code. So what is the command code that we are selecting means whenever we need to change any settings, that is initialization of LCD or cursor, setting the cursor position or changing the position of the cursor, to switch on the LCD or switch off the LCD. So all those things at the time we'll use this command code register, right? So if we want to send any data to the LCD, if you want to display any data, to the LCD, then we'll use this data register for sending the data. So at the time we'll make RS is equal to 1. We'll make RS is equal to 1 at the time. So here two things that we need to observe here. So whenever RS is equal to 0, we are selecting a command code. Whenever RS is equal to 1, we are selecting the data register. So to display the data, we will make RS is equal to 1, and to initialize the LCD, we will use this command code, right? So as I said, like we are having two things are there. So the instruction command code is selected. So allowing the user to send commands such as clear display, cursor at home position, etc. So whenever if you are making RS is equal to 1, the data register is selected. So allowing the user to send data to be displayed on the LCD. So if you want to display hi, welcome all, so at the time we'll make RS is equal to 1. So to clear the screen, whatever the existing data that is there, to clear the screen, so at the time we'll use this RS is equal to 0 command, 0 instruction. Then next read or write. So read write instruction. So this is used to read or write to the LCD. So whenever we are having read write is equal to pin means we are reading the data from the LCD. Whenever we are making read write this pin is equal to 0 means we are writing. So these three pins are very much important while writing the program. So whenever we are having read write pin, so if read write pin is equal to 0 means we are writing the data into the LCD. We are writing the data to the LCD. So whenever we are making the read write is equal to this pin, we are making read write pin is equal to 1 means we are reading the data from the LCD. We are reading the data from the LCD. We are reading the data from the LCD. So these two commands we are using for, these two we'll use for the to write or to read the data from the LCD, right? Then next we are having one more important register, one more important one is enable pin. Enable pin. So this enable pin is used to latch the information to the LCD. Enable pin is used to latch the information to the LCD. So whenever we are writing a data to the LCD, so we have to make this enable pin, we have to give a high to low pulse to the enable pin. Then that information will be latched or will be stored in the LCD. So this LCD, this high to low pulse should be minimum of 450 nanoseconds. This high to low pulse we have to give minimum of 450 nanoseconds. So these three settings we have to compulsorily follow while writing the program. The program for the LCD interface is very easy. So we'll see how to write the program for in the LCD. So as I said, like we are having the read write information where if we want to read the data from the LCD, we'll use read write is equal to 1. If you want to write read write is equal to 0, that is we are writing the into the LCD. The enable pin, so as I said, the data is supplied to the data pins, then we have to supply a high to low pulse to this enable pin so that the information will be latched and it will be displayed on the LCD screen. So as I said, the minimum, the supply that we have to, the minimum pulse width that we have to give is 450 nanoseconds wide. The enable pin we have to give. So now we'll see so these are the general commands or general code that we will be sending to the LCD to display the contents, right? So here, so if you are sending the 01 value, so what will happen means that is it will clear the display screen. So while sending the 01 value, so we have to make RS pin as 0. If you are sending RS pin as 0, then the command register is selected. If you are sending RS is equal to 1, then the data pin is selected. So at the time, so to clear the display screen, we are sending the value as 01. So to display cursor on and blinking the LCD means we will write the value as 0E. 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 So as I said, like whenever we are sending any value to the LCD to display cursor on and everything, the settings that we need to do for the LCD is we have to make the LCD value RS is equal to 0 for the command code register. For the command code register, we have to make RS is equal to 0 and we have to make read write. Since we are writing, we have to make RW read and write should be 0 and we have to make the enable pin as we have to give a high to low pulse. Enable pin we have to give a high to low pulse. So based upon the program, based upon the settings that we need to give, that will select the different command codes or different hexadecimal codes. So 1 means this one, 0E means display on cursor blinking, 06 means increment the cursor position, that is we'll start incrementing from left to right. Then 38 means 2 lines and 5/7 matrix and 84 means cursor at line 1 and position 4. So depending upon the where we need to start displaying whatever the message that we need to display, so that cursor position will be selecting and will be sending the value as 84 or 38 or 06 or 0E or 01. So depending upon the value that we are selecting, we can send the value. Now we'll see the general design or general connection from 8051 to the LCD. What are the connections that we need to do the connection? As I said, like now there are 3 important registers are there in the LCD. So that is register select, read write and enable pin. So to these 3 pins, we need to connect a port. So that's why we have taken a port P2.0, P2.1 and P2.2. These are the 3 ports, 3 in the port 2. We are selecting 0th position, first position and second position, where we are having the register select, read write and enable pin. Register select, read write and enable pin. So from P2.0 to register select, we are connecting one line, and from P2.1 to read write, we are connecting the second line connection, and from P2.2 to enable pin, we are connecting the third line. So third connection. So while connecting this one means, so whenever we need to do any changes in these register select or read write or enable pin, we will be sending those values from P2.0, P2.1 and P2.2 correspondingly. So to send a value to this one through 8051 microcontroller, through this pin we will be sending the values. Then accordingly it will change the values in the register select or RS or read write or enable pin. So if you want to select, for example, P2.0, so we'll be sending the value as 0 if you want to select means 0 if you want to select to the P2.0 means, then at the time we will write the instruction simply, instruction as move P2.0 comma hash 01 like this. Move P2.0 comma hash 01 or we will be sending the values so like move or, so we have to make the RS register select is equal to 0. So at the time we will write the instruction as clear P2.0. That's all. Clear P2.0, this indicates that now we are selecting the register select as it will become as 0. So whenever we want to send any value to this one, we can use, since it is a bit addressable register or bit addressable instruction, we can use set B or clear instruction. So where set B instruction indicates we'll select it as 1, clear instruction indicates we are selecting it as a 0 instruction. So the other pin connections that we are using here is, so where we need to connect from port 1 to port 7, total 8 pins, here D0 to D7. Then for adjusting the contrast level of the LCD, we are taking the 10 kilo potentiometer, where we will be adjusting the contrast of the LCD. So if you are moving towards the ground means the contrast will be increased. If you are moving towards the potentiometer, you are varying to VCC means the contrast will be less. So these are the connection that we need to give for the LCD. So the simple connection that we have seen here is, so 3 ports, 3 in port 2 we have taken these 3 resistors, only these 3 resistors are used. So from port 1 to port 7, D0 to D7. So we have ground, VCC plus 5 volts and for a variable potentiometer. So this is a simple diagram where we will connect it from 8051 to the LCD device. Now we will see how to write a simple program where we will be sending the values to the LCD and writing the program, how to write the program, that we will see now. So as I said, like we are having a command register or a command code, and we are having a data register. We are having a command code or we are having a data register. So we will be always calling these two functions from the program. So whenever we want to clear the display or set the cursor position, at the time we will use this command code register. So we are having 3 registers are there: RS, read write and enable pin. RS, read write and enable pin. So here we are having again 3 registers are there. So that is RS, read write and enable pin. What we have to give here, we will see. Enable pin, read write register. Enable pin, read write system. Right. So this is connected, the RS is connected to P2.0. RS is connected to P2.0. RS is connected to P2.0. Our read write is connected to P2.1 and enable is connected to P2.2. Here also same thing. RS is connected to, here also for this one also RS is connected to P2.0. Read write is connected to P2.1 and enable is connected to P2.2. So these are the connections that we have given already. So as I said, whenever we are making RS is equal to 0 means, whenever we are making RS is equal to 0 means, RS is equal to 0 means, we are selecting the command code register. Whenever we are making RS is equal to 1 means, we are selecting the data register. So whenever we are writing the information, we have to write this RS read write is equal to 0, read write is equal to 0. So here same thing, we are writing the information. So we have to make read write pin as 0. And enable pin, we have to give always a high to low pulse. A high to low pulse here. So here also we have to give a high to low pulse. So this is the general instructions, general things that we need to remember while writing the program. So where are these are the pins, those are the pins for the data register. So the only one change between command code and the data register is, if RS is equal to 0 means it indicates we are selecting the command code. If RS is equal to 1, it indicates we are selecting the data register. So now we'll keep this as this thing. So now we'll write the program to the LCD. So as I said, for a quick reference, we are having these values. We'll use these values to display. To initialize the LCD, we need to send the value 38. To display on cursor on, we need to send value 0E, 01, 06, 84 like this value. So first we'll write the program org 00h org00h and we'll send the program move a comma hash 38. First we'll write, then we'll call a function a call command write. A call command write, and A call delay, A call delay. So for all these values, these 4 lines, these 2 lines will be common. So how to write what is command write program is, so command write, this is the function that we have written there. So we'll take the value into the port 1, so port P1 comma A, port P1 comma A. So in the last session we have seen, like, where for what values, if we want to select the command values, we need to select RS is equal to 0, we need to read write register P2.1 as 0, and we have to enable a high to low pulse. So these, keeping these 3 into view, so now we'll write the program for P2.0 is connected to register RS. So that we are writing the clear P2.0. Clear P2.0 means we are making the RS is equal to 0. So that is, we are selecting the command code, right? Then next, clear P2.1. Clear P2.1 means we are writing the data into the LCD. So that is, we are writing the data into the LCD. So then next, what we have to do, we have to enable the to latch the information, we have to give a high to low pulse. High means set B P2.2 and A call delay and clear P2.2. So as we have seen, enable pin we have connected to P2.2. So that is, we are giving a high, a low pulse of 450 nanoseconds. So this is the simple 4 lines program or 5 lines program for command write. So the next, if you are calling the function as data register, if you are calling the function as data register, now itself we'll write the program. So for the data write, so as I said, like, we'll be taking the value from port 1, whatever the value that we need to display, those values, then clear, sorry, not clear. So we need to make, for selecting the data register, we need to make RS is equal to 1. So set B P2.0. Then we are writing the information to the LCD. We have to make RS is equal to 0. So we are writing the clear P2.1. So then next, enable pin, we have to give a high to low pulse. So we are giving a high to low pulse, so that is set B P2.2 A call delay. It is A call delay means absolute delay, where the range will be 16-bit, 8-bit range. So then clear P2.2. So these are the 5 lines that will be, so where we are making RS is equal to 1, we are writing the information, we are giving a high to low pulse. So this is the program for the data write. Then the next thing is for the delay program, where we are calling for the delay. So the delay program is, you can take any register, move R3 comma some 50, move R3 comma 50. So we'll use 2 loops for writing this program. So where we'll use move R4 comma hash 255, move R4 comma hash 255. Then we're using the decrement jump not 0, comma R4 comma here, decrement jump not 0, R4 comma here. So here we will be calling. So this is the internal loop, where for each value of R4, we are decrementing R4 by 1 and checking whether R4 is 0 or not. If it is not 0, we are coming to the same line. So this loop or this line, the program will be there for 255 rotations. Then next the decrement not 0. So djnz R4 comma, sorry, R3 comma, here. Again, we will be calling here 1. Here 1. So, for each value of 50, the register R4 will be rotating 255 times. If it is 50, 255 times. If it is 49, 255 times, like that, the delay program is written here. So, as we have seen the main program, so where we are sending a value and we are calling the command code. So like that a call delay. So next we are sending a value, for example, move a comma hash 0e, move a comma hash 0e, a call command write, a call command write. So then we are calling some delay for display the LCD. So we'll write the program for all these lines. So this is the simple program. So first we need to send a value, call that function, send the value, call that function, then call the delay program. So for all these 6 values, we'll be sending the program. Yeah, next we will see how to select the data register. So to select the data register, as I said, like we need to give RS is equal to 1. So now we need to display a message in the LCD as no. So for that one, what we need to write is move a comma hash n, and so this is the message that I need to display n and o. We'll call the function a call data write and a call delay, and we are sending one more message, move a comma hash o, and call the function as data write, or we can write as a call data write and a call delay. So already we have written the 2 functions for command write and the data write. So N and O will be displayed in the corresponding LCD. So where if you are selecting the data write as equal to data write means this is the program. So at here, since this is a function, we need to write RET. For back also, here we need to write the function as RET. And for the delay program, so that is the last line. So this is RET and end of the program. So these are the simple lines for writing the program to the LCD, where it will be displaying the message as no. So once if we are selecting the value, if we are sending the value n, so that will be kept in the port 1. Since RS is equal to 1, data command is selected, and we are writing the value as n, and we are making the high to low pulse, then the message will be displayed on the 16:2 LCD as N and O. This is the output of our LCD, where we have selected the line 1 and position 4. We have selected the line 1 and position 4 will be selected. So this is the message that will be displayed on the LCD. Thank you very much. Thank you for giving this opportunity.